So this is the Gini coefficient as seen through capitalism and socialism. So the Lorenz curve is a function. If you look on the graph to the left, it's that little red curved line right there. The curve represents the distribution of wealth or income. The input of the function, L of P, is the bottom percentage of a population. The output of the function is the percentage of total income that the bottom percentage of the population earns. The Lorenz curve is the income distribution and is compared to the line of inequality, which is the straight line as you can see on the graphs there. This line is the function y equals x. It represents the perfect situation where the bottom percent of the function earns all of the total income. With the Lorenz curve and the line of inequality on the same graph, it is possible to see how even the distribution of wealth is in a population. This is important for an economy to see how equal a society is financially. When discussing the Lorenz curve, it is also important to mention the Gini coefficient. The Gini coefficient is the ratio of the area between the line of inequality and the Lorenz curve to the total area. The area between the line of inequality and the Lorenz curve is represented by A, and the area below the Lorenz curve is represented by B. The function is then interpreted as A over A plus B, as you can see in the example there. The Gini coefficient will always be a value between 1 and 0. The Gini coefficient represents how equal the distribution of wealth is in a population. The lower the coefficient, the more equal the distribution. A higher coefficient means a less equal distribution. All countries have different Gini coefficients because they have different economies. For example, the United States, as of 2016, has a Gini coefficient of 0.411. However, Ukraine has a very different Gini coefficient of 0.261 as of 2018. The United States has a drastically larger Gini coefficient than Ukraine, and it shows that Ukraine has a more equal distribution of wealth in its population. This is not surprising because Ukraine is a mostly socialist country, and socialism is known for its promotion of equal distribution of wealth. However, the United States is a more capitalist country, and capitalism tends to support a more uneven distribution of wealth. This data shows that Gini coefficients are highly influenced by what type of political philosophy a country governs under.
When researching, we noticed that there may be some factors that can contribute to whether or not a country has a high or low Gini coefficient. One of such factors is the economic philosophy. Different economic systems have very different beliefs regarding distribution of wealth. Two philosophies that differ extremely are capitalism and socialism. We selected two countries, the United States and Poland, to collect data for. Using the data from those two countries, we attempted to answer the question, does economic philosophy of a country have an effect on the distribution of wealth?
So we collected many data points for the United States and Poland, around 40-ish for each. We had slightly more data points for Poland than the United States. We obtained the number of people in a certain mean or total income. For the United States, the data was able to be collected from the U.S. Census Bureau and Sweden from the website Statistics Sweden. You can see our data to the right. We sorted it in ascending order and put it in an Excel sheet.
Once the data was sorted in ascending order, the population size was labeled as XI and the mean income as HI. The total income for each group was then calculated as XI HI. For each group, the percentage population was calculated. We found this by dividing the total population, then the cumulative percent income was calculated. This was found by dividing the total income for each group by the sum of all incomes and adding them together. The percentage population and cumulative percent income was then plotted against each other to make our graphs. For each country, we created two graphs, one graph containing a linear regression line with linear equation. The other graph contained a quadratic line of regression and a quadratic equation.
So this slide shows our linear model graphs. We've graphed the cumulative percent income versus the percent population, and then we put our lines of regression. Obviously, these ones are the linear lines of regression, and as you can tell, they don't exactly fit our data points very well. This will lead to some error when calculating the Gini coefficient. So using our Lorenz curve that we've created and the line of inequality, we're now able to calculate that Gini coefficient. We do this by numerically integrating using the equation of linear regression, which is the two equations that you can see on our graphs there, and then we use that to calculate it.
This slide shows our quadratic model graphs. The quadratic regression line represents our Lorenz curves much more accurately than a linear regression line. Just by looking at the graph, you can see that the quadratic model should lead to more precise Gini coefficient calculation. Just like the linear regression line. We used the equation of the quadratic regression line and the line of equality to numerically integrate and calculate the Gini coefficient for each country.
So here you can see how we were able to calculate the Gini coefficient. We used the formula 2 times the integral from 0 to 1 of the line of inequality minus the Lorenz curve. The equation for the Lorenz curves were the equations of the lines of regressions generated on our graphs. After plugging in those equations, we were able to simply evaluate the integral and the rest of the expression to find the Gini coefficient for each model. For the linear models, we calculated the United States to have a Gini coefficient of 0.4491 and Poland to have a Gini coefficient of 0.2616. The quadratic models resulted in a slightly lower Gini coefficient for each country, the United States calculating to 0.4204 and Poland calculating to 0.24993. So we also calculated the Gini coefficient using Simpson's rule. We had to come up with our own formula because we had uneven intervals. So using the trapezoidal and midpoint rule, we were able to calculate a general form for these uneven steps. This can be seen in the two pictures on the left, how we got to that equation. And after calculating this formula, we used it to find the Gini coefficient for each country. We plugged the rule into Excel and calculated the United States to have a Gini coefficient of 0.443515735 and Poland to have a Gini coefficient of 0.354196449. This fits the general pattern of the United States having a higher coefficient than Poland. However, this number calculated for Poland is significantly higher than the other models, as this one is a 0.35 number and the other ones were all around like 2.6, 2.5-ish. So there does show signs of some error here. So these are all the Gini coefficients calculated from each graph and through Simpson's rule. So linear graphs resulted in the United States having a 0.4491 and Poland having 0.2616. For quadratic, the United States had 0.4204 and Poland had 0.244993. And for Simpson's rule, the United States had around 0.4435 and Poland 0.35419. As you can see, the United States had a significantly higher Gini coefficient than Poland for every single method. And it's also apparent that each method led to slightly different values, so some of them may be more accurate than others. But they all fit that general pattern of the United States being significantly higher than Poland.
We believe the Simpsons rule would be much more accurate than the linear model because our data does not exactly fit the model. We are basing our results on a linear line of regression. This does not exactly fit to our data, so there is more room for error. However, the quadratic line of regression would be the most accurate because it most closely resembles the curve of our data. The United States and Poland are very different countries. This is why we chose them to study. They differ extremely in economic system. The U.S. is classified as capitalist and Poland is classified as socialist. The dictionary definition of socialism is any of various economic and political theories advocating collective or governmental ownership and administration of means of production and distribution of goods. Capitalism is defined as an economic system characterized by private or corporate ownership of capital goods, by investments that are determined by private decision and price products, and the distribution of goods that are determined mainly by the competition in a free market. Socialism is rooted in equal distribution of wealth, whereas capitalism is rooted in the priority of personal gain through competition of a free market. We predicted that Poland would have a lower Gini coefficient, and this is because lower Gini coefficient means that the wealth is distributed more equally. Our data and calculations proved that to be correct. The United States had a higher Gini coefficient than Poland, following the trend of unequal distribution of wealth associated with capitalism. The result of our data answered our question that the economic philosophy of a country does have an effect on the distribution of wealth and income. Socialism causes us lower Gini coefficient and more equal distribution of wealth. Capitalism causes a higher Gini coefficient and a bigger inequality in the distribution of wealth.
These were all the resources we used to form our research question, collect data, and draw conclusions. Thank you for watching our presentation.